All right, we're going to take a look at the following problem here. They give us this quadrilateral, and we know that line segment BC plus line segment CD, we know that sums to be 12, and they want us to find the area of ABCD, so the area of this quadrilateral. We're going to tackle this problem, first thing we're going to do is we're going to turn this into two triangles. Drawing a line down here. We're then going to label our hypotenuse here. Since I've got angle C here, I'll label this with a C. All right, and we're going to make the observation that there's two ways we can express C here. I know that if I view the bottom right-hand triangle here, I know that C squared is going to equal, let's label these with x's, let's say, will be x squared plus x squared. So I know I can represent C squared as being 2x squared. But if I view the top right angle triangle here, I then know that C squared will be the sum of these legs of the triangle here. So I'm going to go ahead and label this. Let's just call this A and B. So I know C squared is also going to equal A squared plus B squared here. So therefore from here, I know that it must be the case that 2x squared equals A squared plus B squared. So at least we have a relationship now between our x's, our a's, and our b's. So notice the way I've partitioned this up here, I already know that in this case here, the area of this shape, which is what we want to find, this is our S value here. The area of this shape is going to be the area of the bottom triangle will be base times height divided by 2. So that'll be x squared divided by 2. Plus the area of the top triangle will be base times height, again, divided by 2. So this is our expression for the area. We have to figure out how to get that. And the only thing I have to work with now is I know the following. 2x squared is A squared plus B squared. Now one thing we do know is from this relationship here, I know that A plus B must equal 12, right? As this is my line segment BC is A and CD is B here. So we're going to make the following observation. We are going to observe that A squared plus B squared is equal to A plus B quantity squared minus our 2AB here. Now we know that A plus B, I can get rid of this A plus B, I can change that to a 12 squared minus 2 times AB, in which case here I know that A squared plus B squared is going to equal 144 minus 2AB. That means that now I know that A squared plus B squared is equal to 2x squared, and also A squared plus B squared is equal to the 144 minus 2AB, which is looking a lot like the formula we have here. So make the following observation here. From these two, combining these two ideas together that we have highlighted in gray, it must be the case that 2x squared is equal to 144 minus 2AB, or 2x squared plus 2AB is equal to 144, and therefore x squared plus AB is going to equal here 72. Now that we have that, take a look at our area formula. We're almost done here. My area is really can be written as 1/2 x squared plus AB, but as we just discovered here, the x squared plus AB, as we just found out over here, is exactly equal to 72. So cutting that in half, the answer is 36 square units. And then we have the area of our shape here. So again, this little geometric problem, you break it up into two right-angled triangles, and then just get a relationship using Pythagorean theorem of our hypotenuse together here. You can see I represented in two different forms, equated them, made this little observation here, and I did that because I wanted to incorporate the A plus B relationship that we had been given to us in the question, and that allowed me to make this observation and find out that x squared plus AB is 72, and therefore our final answer, the area is 36.